Hello everybody. In today's video we are going to be talking about triangle similarity using angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Now you'll notice a couple of these are similar to what we used for congruency, where we had side-side-side and side-angle-side, but in this case we also have angle-angle similarity, and the reason this has to be true is because as long as we know two of the angles are similar, that means the third one also has to be similar because they both have to add up to equal 180. And if all three of the angles are the same, then we know the triangle is at least similar, right? It could even very well be congruent if the sides are also equal, right? But it's at least similar. So we can prove two things are similar if two angles are similar as well. So let's go ahead. This is going to be a useful cheat sheet for you for this. So let's go ahead and go over number one first. So angle-angle similarity is if two corresponding angles are congruent, then we know that the triangles are similar. So if we look at number one, it's really just straightforward, right? We have 75 right here, right? And that corresponds with this 75 over here. So we have one set of similar angles because those are congruent, right? Remember, angles have to be congruent. And then we also have, I'm going to try to put this one in a square just to show that it's different. We have 31 for this one. So we have two sets of similar angles. So determine if they are similar. If yes, write a similarity statement. So in this case, of course, they are similar. So yes. And then we can say ABC is similar to triangle DEF. All right, perfect. Well, let's look at number two, okay? And you're going to see some like this, right? Where they don't actually give you numbers, but they still want you to know, can we find congruency here? Or can we find similarity through congruency? So, well, let's see. I see a pair of vertical angles. Do you see a pair of vertical angles? There they are, right there, right? So we have one angle that's similar because we have V and Y, right? Those are similar angles. And then both of these angles for X are also similar. So we can say, yes, we have two sets of angles. Yes. And then it is triangle VWX is similar to triangle YZX. Yay! That's a Z, by the way. YZX. All right. So angle-angle similarity is kind of simple, right? We just need to find two congruent sets of angles, and then we're good. Now, angles are simple. Sides are a little bit more complicated because with sides, we are worried about congruency, not similarity. Or we're worried about proportions, not trying to find things that are equal. So if we look at number 3, right, you can see that for this here, we have a 5 and we have a 10. Those obviously aren't going to be the same because they're not congruent triangles, they're similar triangles. What we have to prove is that the ratio between all of the sides is the same. And we literally mean all of the sides because we're doing side, 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 right? So let's look at this real quick. If we look at number 3, we know that this 3 is going to correspond with the 6 over here. So 3, 6 has to equal 4 over 8, which has to equal 3, 4, 5 over 10, right? The last one. So now let's look at this. What do these all reduce to? Well, 3/6 is 1/2, 4/8 is 1/2, and 5/10 is also 1/2. So this is good. All of the sides are proportional. Therefore, yes, we do have triangles, and I'm going to say triangle PQR is similar to triangle STU. All right, excellent. Now let's look at number 4. It's the same exact concept. We have to see if the matching sides are proportional. So we have 30 over 24 has to equal 35 over 28, which has to equal 32 over 25. All right, well, do these match up? No. And the reason I know that is because 30 over 24, even if we take the maximum number out of these, which is just 3, right? This is going to give us 10 over 8. I guess I could have taken out 6, right? Because then this would be 5 out of 4. So 5 out of 4, but if we come over here, the 25 is going to reduce to a 5, right? Actually, there's nothing to reduce here, but 25 is just made out of 5 and 5, right? So there's nothing we can reduce. None of this is going to work, right? So these are just simply not congruent, right? Or not similar. Not similar. Okay. All right. I'm going to write not similar. Okay, now let's look at number 5. So for side angle side, we have to know that the two sides are proportional, and then the angle in between the two sides are congruent. So here we have to know that 8 over 6 is the same as 20 over 15. We have to know that that's true. And then we also have to know that the angle in between them is also the same. In this case, we know n and k are the same, they told us. So as long as these are congruent, we are good, right? And in this case, if we reduce them both here, we're going to get 4 over 3. And if we reduce both of these by 5, we'll also get 4 over 3. So yes, these are congruent. They both reduce to 4 over 3. If you want to write this just to like kind of give yourself a visual, right? They both turn into this. So yes. And then if you want help with the statement, we can just say, let's say JKL is similar to MNP. Perfect. All right, finally we have number 6. Well, first of all, angle A is going to be congruent to angle A, right? Because it's the same angle for both of them. So we know the angle is fine, but now we just need to match the sides. So we have 15 over 25. Does that equal 12 over 21? Well, 12 over 21 is literally not going to reduce. So we know it's not that. So what else do we have? 25 over 50. Yeah, this isn't going to work because 15 over 25 can be what, 3 over 5? That's not ever going to work out. So this is not going to work. Not congruent. And we know that because we could not prove, or not similar. I keep saying congruent. I'm sorry. We're talking about similarity. Not similar. And that's because these sides are not proportional, right? Okay. Real quick, I'm just going to go over one of each of these with you guys. So we have angle similarity. Basically what this is we need to find two of the angles, right? So if we look at this, well, we have parallel lines, which means we have, in this case, alternate interior angles, right? We have this guy, angle C, and angle G are alternate interior angles. Actually, for this one, it's kind of neat because we know angle F and angle D are also alternate interior angles. And then we actually know angle E is the same on both sides, right? Because those are vertical angles. So we know all three. So in this case, I'm just going to write yes. If you want help writing the similarity statement, you can. But that one's good. So now let's just look at another one, right? Let's go down to number 4, just so I can show you one that looks like this as well. So if we look at number 4, in this case, there's really only one trick to it, right? They tell us 2 of the 3 angles. So all we need to do for each one is make sure that the angle makes sense. So if this one, we have 68 and 54, right? 68 plus 54, and you subtract 180. So this would be, what, 58 would be our last number, right? And if we look over here, like, none of these are matching up, right? This is not going to be congruent, right? Because we need at least 2 of these to match. It looks like we got one of them to match, but the other 2 aren't. So no go there. All right, let's do a couple for side, 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 just to make sure we've got this down. So side, 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 we need everything to match up, right? So let's do this real quick. So we need 9, let's see. Well, first of all, let's just match these up, right? It looks like the base here is 21, and the 21 is going to go with the 13. So I'm going to just write it over top just to make it easy. And then this is the hypotenuse-ish thing. So this one's 31.5. And then this one, of course, would be the 14. So I'm going to write the 14 over top. And remember, usually I would put them underneath, but as long as we put them all in the same spot, it doesn't really matter. So now we have to see if this makes sense. So 14 over 9, 21 over 13.5. Looks like we're increasing them all by 2/3, 2/3. So this is actually a really annoying problem as far as the numbers go. But just trust me on this. These are all actually proportional, right? 14 over 9. If you multiply each of them by 3/2, you're going to get 21 over 13.5. And then the same thing is it like if you multiply that by, 1.5? Same thing. You'll get 31.5 over 20.25. So those are all congruent. You'll just trust me on that. If you want to put them into a calculator to reduce them, you can. But yeah, as long as all three of them are equally proportional, then we are good. So we found that they're proportional, so that's good. So let's move on to one with a little bit more reasonable numbers, such as, well, not number 10. They don't like reasonable numbers this time, do they? Let's see. Well, we could go with let's just do number 9, okay? I promise on the exit tickets I'll give you ones that are like there's no reason to make this complicated. So we have, it would be what, the 5 would match up with the 4. So I'm going to write the 4 here. The 10 is going to match up with the 16. So I'm going to put the 10 here, which means the 12 matches up with the 7. And I'm just visualizing this, by the way. They don't give us any kind of statement that helps us out. So you just got to kind of look at it. Usually we're doing this to kind of lead into proofs, but this will help us. So 7 over 12, 4 over 5, 10 over 16. I mean, we can even just take the 10 over 16, right? We know this is going to be 5 over 8. So these are not going to match up at all. These two here, these don't match. So this is not going to be, this isn't going to be similar. All right. So yeah, so that's another example of side, side, side. And that one is not congruent, or not similar. So let's go to side, angle, side, where we need 2 sets of congruent sides, and we need a angle in between. So let's just look at number 13. This will be the last one we do. So we have 24 and 6 would be the ones that match up. So I'm just going to do like 6 over 24. And that has to equal the other one, which is 12 over 48. And in fact, if you take both of these numbers over here, both of these two here, and divide them each by 2, you get 6 over 24. So these are the same thing, right? So in this case, yes, they are similar. All right. So yeah, if you have any questions on the other ones, let me know. I can show you a trick on how to do anything that has a decimal in it. There's a trick to it. So if you have any questions, let me know, and I will see you in the next video.